Hello and welcome to the video. In this video we're just going to continue on with our numeric data types. We'll discuss the numeric data types available when we're storing floating point or decimal numbers. In the last video we talked about the float, the 32-bit IEEE 754 single precision data type. And in this video we're going to continue on to this topic. We'll move on to what is the double. Going all crazy here, and here we go. So now the double is a 64-bit IEEE 754 standard, and we call this one the double precision, hence the name that it gets. Now the double is way more precise than the float. It's kind of the go-to. It's kind of the one you're probably going to use for the most part. So this one here is rather straightforward. And it doesn't have all these little weird nuances that, first second, we'll call it first double. And we'll just jump down a line, create our next one. And we'll make a double result. And here we go. So it doesn't, as we showed up here, you couldn't put an actual decimal point in. It kind of went weird and resolved to, it wouldn't allow us without typecasting or making it a floating point literal, which, you put the F at the back of it. You can use double, not there, you'd have to put it down here when signifying it, but it's a weird one to use, and there's a little bit of knowledge on using it. Now the float, or the double here, this one actually, we can go, put in all sorts of different values in it without actually having to go that extra distance. So it's kind of the go-to one. It's kind of the one you're actually going to probably for the most part go with. It's the one handy for, money, doing any kind of real mathematics with decimal points. I would stick to the double. I would almost always use a double instead of the float. There's a time and place for the float, but usually not anything that's really particular. So now, print line, here we go. Now I'll show you a couple things about the floats as well that you should be prepared to understand with the double as well. When these numbers get pretty big, they start to represent themselves a little differently, but see if we can get that to happen. So here we go, result double, put that there. This is obviously not going to work because we haven't actually declared this. Now, I kind of wanted to show that too. When we declare these, you should always, here it says, if we hover, the double might not have been initialized. So the double really has nothing in it. And if we try to print it out, it's going to give us some weird data, and it will give us some very weird data indeed. So we always kind of want to, when we create or declare a variable like this, you just kind of want to give it the default value just so that it has a value instead of just having nothing, in case you messed up somewhere, you missed out on something, it didn't quite work out in the calculation. It's not going to be calculated on a whack number or something. It might have been value stored previously. It could be something totally whack that was stored in that chunk of data beforehand. Like, that's when things just get right out of hand. So it's a good thing to initialize it properly and just set it to a default value. This isn't necessary. It's not 100%. It's kind of just a good programming practice. I mean, if we come down here and we're going to use the value, and we'll say first underscore double, and we'll multiply it by the second. Fairly simple. We'll close it off with a semicolon every single time. We got to finish that there. So now we've now initialized it, or we've set the value. So it's not necessarily overly important to do so, but it just does help to make code clean and keep it uniform, and you're not getting unexpected values. There may be reasons why you can use this later. I'll explain more once we get into like data validation and different reasons when we should, you know, check for values. But for now, let's just keep on the double precision 64-bit working with decimal places. So if we run this code, we'll get out an absolute decimal point. And here we go. There we go. So now it pops it out without absolutely any problems whatsoever. This might be unideal for you. You know, you may be doing something scientific where you need all these decimal points. If you're working with currency, then you definitely don't need all these decimal points behind it. You know, 1051 will work perfectly fine. There is ways to format the output, but in this video we're not going to talk about formatting the output. We're just doing this to kind of give you the idea of when to use certain data types and what variables are available to you to use for future reference. And these are pretty much every one of them that are, you know, the basics anyways: the byte, the short, the int, the long, the float, and the double. For the most part, you're probably going to resolve to a int and a double. The long gets in there every now and again. The byte and the short, just a time and place thing. They are kind of limited to their range. So, you know, if you got somebody's age and you want to store it here, we'll talk more about when to use these and pick them. But for now, the int and the double are probably your most likely candidates to picking. So in this case, that's decent. That's how it works. Let's just take this right here, for example. We're going to pop this number in here. We'll multiply it by 5 and we'll run that. Let's just see what happens here. This is a 2 billion number. And now you might notice this is kind of a weird thing at this point. You see 1.7. This is 2,147,000,000 times 5. And we're getting 1.0. Okay. Something's definitely out on this number here. But what you're actually not seeing is it's showing it to you in scientific notation. And right here, this E. So this is technically the number right here that we're actually working with. This would be the exponent to 10. So in scientific notation, I can do a video if you're unaware of that. You're technically doing, if this is a positive number behind here, you move the decimal place to the right. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We pop that decimal there, and now that's your actual number that you're looking at when it comes down to the true number that we're working with. So when we get really high up in here, you just want to watch that you are working in scientific notation. Now engineering notation would be a base of 3, so we know that if this was only in 3, 6, 9, it'd be an engineering notation, but in this case it's scientific because it's just giving you single multiples, or just every other multiple. Every multiple is in scientific notation. So this actually also works the opposite way as well. So say if we went -2 and we went down this way, this might actually be weird. Oh yeah, no, it didn't work out the way I actually had planned it to. We're trying to make a small number. Oh, here, we'll go 0.0. Oh, there we go. Let's see if this actually pops out now. Yeah, well, it didn't actually give it to us in scientific notation because the number didn't actually need to be represented in scientific notation. But you get the point. It'll be a negative number at the back side of it. It'll show you the exponent. But anyways, that's just some of the little small things to watch out for. You know, you want to watch out for when you're producing a value. It's not going to actually be, you know, you might want to print this whole entire value out when working in more of your scientific fields, or, you know, you're not going to just give your customers went in there with $2 billion and he wanted to make whatever, you know, he multiplied that by 5 because it was a cost of something. You're going to be like, sir, it's only like $1.07. You got to watch the values that you're popping out. So just so you're aware of that, it is what it is, so you do know. But that is the double. That is our data types for the most part now. And we'll get into actually talking about data inputs and getting some inputs happening, so we can kind of create a little program and get more interactive with these programs instead of you just listening to me talk about all these boring bits of information. But I do appreciate you watching the video. If you do like the video, give it a thumbs up. If you have any comments or questions or ideas for future videos, be sure to put it in the comment section below. Turn on your notifications and subscribe, and catch you in the next video. Thanks for watching.